हेलो दोस्तों, कैसे हो आप लोग। तो आज हम लोग करेंगे रिलेटिव मोशन और इस वीडियो का पर्पस है कि आपकी जो रिलेटिव मोशन की बेसिक थ्योरी है उसे अच्छे से क्लियर कर दे। अगर वो क्लियर हो गई तो हमारा इस वीडियो का जो पर्पस है वो सक्सेसफुल हो जाएगा। इसके आगे भी मैं रिलेटिव मोशन में वीडियोस बनाऊंगा, बट दोज वीडियोस विल बी बेस्ड ऑन प्रॉब्लम सॉल्विंग कैपेसिटीज और प्रॉब्लम सॉल्विंग कॉन्सेप्ट्स रादर देन वर्किंग ऑन द थियरी। ठीक, तो अभी हमारा काम ये है कि वी ट्राई टू अंडरस्टैंड व्हाट इज रिलेटिव मोशन एंड हाउ इट वर्क्स एट द फर्स्ट प्लेस। ऑलराइट, ओके। तो बिफोर वी स्टार्ट रिलेटिव मोशन वी मस्ट अंडरस्टैंड कि रिलेटिव मोशन में दो फंडामेंटल रूल्स होते हैं। अब पहले रूल को समझाने के लिए मैं एक एक करके आपको रूल समझाऊंगा और पहला रूल समझते हैं रिलेटिव मोशन। तो पहले रूल को समझाने के लिए मैं ये मानता हूं कि ये जो आपके सामने पूरा ब्लैक बोर्ड दिख रहा है ये एक्चुअली किसी तरह का सरफेस है। किसी प्लेग्राउंड का सरफेस हो सकता है, किसी भी एक बड़ी एरिया का सरफेस है, और इस सरफेस को मैंने ग्रिड्स में बांट दिया। इस तरह से मैंने अपने सरफेस को ग्रिड्स में बांट दिया। आई जस्ट डिस्ट्रीब्यूटेड माई सरफेस इनटू ग्रिड्स, एंड अपार्ट फ्रॉम डिवाइडिंग माई सरफेस इनटू ग्रिड्स आई हैव डायरेक्शंस नॉर्थ साउथ ईस्ट एंड वेस्ट। I have got directions north, south, east and west. अब आप ध्यान से समझना मेरी बात को। ये आप यहाँ पर हो, you are here. This is you. And this is your friend. And you were playing some kind of a sport where it involved a ball, and here is the ball. Here is the ball. अब मैंने एक सवाल पूछा। आई जस्ट आस्क्ड अ वेरी सिंपल प्रॉब्लम, एंड व्हाट इज दैट प्रॉब्लम? द प्रॉब्लम इज वेयर इज द बॉल। अब जब वो सवाल मैंने आपसे पूछा तो आप मुझे क्या जवाब दोगे? आप मुझे जवाब दोगे दैट द बॉल इज 2 units टुवर्ड्स ईस्ट एंड 3 units टुवर्ड्स नॉर्थ। अब वो यूनिट्स कुछ भी हो सकती है, मीटर्स हो सकती हैं, फिट हो सकती है, आई डोंट नो, बट इट इज 2 units टुवर्ड्स ईस्ट एंड 3 units टुवर्ड्स नॉर्थ। दैट इज द पोजीशन ऑफ द बॉल। द आंसर दैट इज गिवन बाय यू। व्हाट इज द आंसर गिवन बाय योर फ्रेंड? द आंसर गिवन बाय योर फ्रेंड इज इंटरेस्टिंग। द बॉल इज 4 units टुवर्ड्स वेस्ट। 4 units towards west. Let me mention these two answers separately. The answer given by you is 2 units east, 3 units north. Right? The answer given by your friend is 4 units west. अब सवाल ये उठता है कि क्या बॉल की पोजीशन चेंज हुई? Does the position of the ball change? And if not, then why are we having two different answers? हमारे पास दो अलग अलग तरह के आंसर्स क्यों हैं अगर बॉल की पोजीशन चेंज नहीं हो रही तो इसका सीधा सा जवाब ये है कि जब मैं आपसे पूछता हूं व्हाट इज द पोजीशन ऑफ द बॉल, तो इसका मतलब आपकी ओरिजिन, आपका कोऑर्डिनेट सिस्टम आपको ओरिजिन मानता है। आप ये मानते हो कि यू आर एट द सेंटर ऑफ द यूनिवर्स। बेसिकली एवरी ह्यूमन थिंक्स दैट, every human mind thinks that, come on, think about it, every human mind thinks that they are the center of the universe. So you are thinking that you are the center of whatever space you are living in, and from that center the ball is 3 units north and 2 units east. Now when we are talking about your friend thinks that he is the center of whatever space he is in, and from that center the ball is 4 units towards west. And this gives us the first law of relative motion, or the first fundamental rule of relative motion. And what is that? Every observer is at the origin of his, her or its reference frame. हर एक ऑब्जर्वर को ये लगता है कि वो अपने रेफरेंस फ्रेम की ओरिजिन पर है। अब इस रूल नंबर 1 को हम थोड़ा सा सिंप्लीफाई करके सोचते हैं. अभी हम वन डायमेंशन में देखते हैं. फॉर एग्जाम्पल वी हैव अ लाइन. ऑन दिस लाइन देयर कुड बी अ जीरो. एवरी लाइन हैज अ जीरो. देयर कुड बी अ 1, 2, a 3, a 4, -1, -2, -3. Now let's say there are two persons here. Person A is at -2, person B is at +3. Now for your convenience, I'll actually write down this observation. Position of A is equals to -2 and position of B equals to -3. Sorry, +3. Now here is the problem. The problem is, where is the observer who is giving these statements? Where is the observer who is giving these statements? What statements? That these two statements, that the position of A is at -2 and position of B is at +3. ये जो ऑब्जर्वर है जो इन स्टेटमेंट्स को दे रहा है, भाई कोई ना कोई ऑब्जर्व कर रहा है तभी तो कह रहा है कि A की वैल्यू -2 है और B की वैल्यू +3. अगर कोई ऑब्जर्व ना कर रहा होता तो कौन बताता कि A की वैल्यू क्या है, B की वैल्यू क्या है? तो वो ऑब्जर्वर कहाँ है जो इन स्टेटमेंट्स का इस्तेमाल कर रहा है, दैट द पोजीशन ऑफ A is -2 and position of B is +3. So you guessed it right, and if you have guessed it, otherwise I'll tell you right now that the observer is at the origin. The observer is at the origin because any observer thinks that he or she is, with respect to, is at the origin. So the observer, the current observer, is at the origin. Now the next question is, what would be the position of OB as an observer, and B as seen by A? What would be the position of OB? OB means this fellow here. What would be the position of OB and B as seen by A? Now if you want to answer this question, all you have to do is first consider that A now becomes the observer. This is the first thing that you have to consider. If you are asking the position of OB and B with respect to A, इसका मतलब ये होता है that A is your observer. A is your observer. Now OB is not your observer right now. A is your observer. Now if A is your observer, it becomes obvious that A is at the origin. So the position of A actually becomes equals to 0 because A is the observer now. And one point to the left of A becomes -1, one point to the right of A 1, 2, 3, 4, 5, 6. I can keep on drawing it. 7, 8, 9 or 10, something, whatever. Okay, just let me drop to this much. Now the position, what is the position of OB? Now if you look with respect to A, the position of AB is 2 units towards right. अगर आप A के रेस्पेक्ट में देखते हो तो आप ये पाओगे कि जो है OB 2 units towards right है. तो OB की पोजीशन हो गई 2. This is the position of OB. B की पोजीशन क्या हो गई? काउंट कर लो. काउंट करने का क्या तरीका है? बहुत सिंपल काउंटिंग है. 1, 2, 3, 4, 5. 5 units towards right. So the position of B is 5 units towards right. The position of OB as seen by A, I want you to see this term very carefully. इसका मतलब क्या होता है? Position of OB as seen by A is actually equals to 2, and position of B as seen by A is equals to 5. Now the answers have changed because A is now your observer. A is your observer. A is your actual observer right now. तो अब हम यहाँ पे एक सिंपल सा मैथमेटिकल फॉर्मूला अगर यहाँ पे पुट करें कि व्हाट इज द पोजीशन ऑफ एनी ऑब्जेक्ट रिलेटिव टू अनदर ऑब्जेक्ट, अगर हम ये बताने की कोशिश करें दैट पोजीशन ऑफ एनी ऑब्जेक्ट रिलेटिव टू एनी अदर ऑब्जेक्ट दैट कैन बी रिटन एज position of B with respect to A can be written as position of B minus position of A, and this is the formula that we are talking about. This is your rule number 1. If you want to verify it, you can see that position of B with respect to A is actually equals to position of B. The position of B in the first diagram is 3 and the position of A in the first diagram is -2. So 3 minus -2 and that is equals to 5 units. So this answer comes out to be the same over here. हाँ है ना? तो अगर आपको एक ऑब्जेक्ट की पोजीशन को दूसरे ऑब्जेक्ट की पोजीशन के रेस्पेक्ट में निकालना है, तो जिसके रेस्पेक्ट में निकालना है वो ऑब्जर्वर है, जिसके रेस्पेक्ट में निकालना है वो ऑब्जर्वर है. लेट मी क्लैरिफाई दिस वन मोर टाइम. If someone asks you or if someone tells you this statement, position of B with respect to A, that simply means that A is the observer. And that also means that A is at the origin. अगर ये कॉन्सेप्ट हमारे दिमाग में बैठ गया कि हर एक ऑब्जर्वर ये सोचता है कि वो ओरिजिन पर है, तो हमसे रिलेटिव मोशन सॉल्व करना एक्चुअली में बहुत आसान हो जाएगा. नाउ लेट अस लुक एट द सेम कॉन्सेप्ट इन 2 dimensions. So this is x axis, this is y axis, and A is here. So let me call A, the position of A, as 2 I cap. What do I mean by I cap? I cap is a unit vector along x-axis. If you don't know what a unit vector is, you should go back to my second video of vectors, and there I have explained what a unit vector is and how do we use unit vectors in the problem of cross products. Now, the position of B is here. Let me mark this position of A and let me mark this position of B, and let us call it as 3 j cap. J cap is the unit vector along y axis. Now obviously, if this is the observation given, then we must understand the fact that whosoever is giving this observation is actually at the origin. This is your observer. Whosoever is giving this observation is actually at the origin. But now we want to find out what will be the position of B with respect to A. The position of B with respect to A. And when we are talking about position of B with respect to A, let me write down the problem statement. Position of B with respect to A. Okay. And when we are trying to find out the position of B with respect to A, that means A is your observer. A आपका observer है, और चूंकि A observer है, इसका मतलब A origin पर है. A observer होने का मतलब ही ये हुआ कि A origin पर है. बहुत सीधी सी बात है, जो observer है वो origin पर है. तो B कहाँ है? Where is B? With respect to A, the position of B can be simply given as, let me write this down. Position of B with respect to A can be simply given as position of B minus position of A. And that is the formula that we discussed in the last case. So what was the actual position of B? That was 3 j cap, and position of A is 2 I cap. So the new position of B as seen by A, B has not changed. याद रखिएगा, B अपनी पोजीशन नहीं बदल रहा है, बस A के देखने का नजरिया बदल रहा है. तो अब जब A देख रहा है तो इसका मतलब वो ओरिजिन पर है, और अगर वो ओरिजिन पर है तो उसे B पहुंचने के लिए पहले 2 यूनिट्स लेफ्ट चलना पड़ेगा, फिर 3 यूनिट्स y एक्सिस में जाना पड़ेगा। अगर A को B तक पहुंचना है तो उसे पहले 2 यूनिट्स लेफ्ट चलना पड़ेगा, दैट वुड बी -2i कैप। फिर 3 यूनिट्स उसे y एक्सिस के अलोंग जाना पड़ेगा, एंड दैट वुड बी 3j कैप। And this is the new position of B as seen by A. And this is how relative position works. We will come to relative velocity part, but this is how relative position works. So what is the concept? Main concept क्या है कि अगर आपको किसी को ऑब्जर्वर मानना है, मान लो आपको A को ऑब्जर्वर मानना है, तो आप A को ओरिजिन पे डाल दो, फिर आप देखो कि आप A से B कैसे पहुंच सकते हो। तो A से B पहुंचने के लिए आपको 2 यूनिट्स लेफ्ट जाना पड़ेगा, तो ओरिजिन से लेफ्ट -2i, फिर 3 यूनिट्स y एक्सिस में, तो 3j कैप। तो 3j कैप -2i कैप इज द कंबाइंड पोजीशन ऑफ B विद रेस्पेक्ट टू A। यही आपका आंसर आ रहा है यहाँ पे, 3j कैप -2i कैप। गॉट इट? ओके, तो यहाँ पे अब हम डिस्कस करेंगे सेकेंड रूल ऑफ रिलेटिव मोशन। एंड व्हाट इज द सेकेंड रूल ऑफ रिलेटिव मोशन? सेकेंड रूल ऑफ रिलेटिव मोशन इज दैट एवरी ऑब्जर्वर is at rest with respect to itself. और इन अदर वर्ड्स हम ये कहें कि हर एक ऑब्जर्वर ये सोचता है कि वो रेस्ट पर है, वो नहीं मूव कर रहा है, उसके आसपास की चीजें मूव कर सकती हैं बट वो रेस्ट पर है। दिस इज व्हाट एवरी ऑब्जर्वर थिंक्स। That is the second rule of relative motion. Now let me exemplify this rule using a very simple example. Let's say we have a tree. This is a tree, and trees are generally at rest. And then we have a car. It's a very bad car to draw, but okay. And then maybe we have a bus. So this is a car, this is a bus, and this is a tree. The car is moving at 10 meter per second. The bus is moving at 18 meter per second, and the tree is at rest. Now, अब मैं चाहता हूं कि आप इस स्टेटमेंट पे गौर करें। Car is moving at 10 meter per second. Bus is moving at 18 meter per second. And tree is at rest. तो इसमें ऑब्जर्वर कौन हुआ? Who is the observer here? आप ये कह सकते हो that observer is the tree, or you can say that observer is possibly a bystander who is standing just beneath the tree and it's not moving. It is standing. The observer is standing on the ground, and the observer sees that the tree is at rest. The car is moving with 10 meter per second, and the bus is moving with 18 meter per second. Now, what will happen if I want to ask you that how will the motion look like? How will the motion look like if observer sits in the car? If the observer goes and sits in the moving car, and then how will the motion look like? So in order to exemplify that kind of motion, in order to explain that kind of motion, the first thing that is going to happen is that since the observer is in the car, the observer will say that I am at rest, because that is the rule, right? That is the rule. Every observer is at rest with respect to itself. So if the observer is sitting in a car, he will say that fine, I am at rest. So the velocity of car actually becomes equals to 0. Your observer is right now sitting in the car. The same observer who was standing over the tree, the same observer is now sitting in the car, and the observer says that I am at rest. So the car is at rest. If I am not moving, then the car is not moving, right? Now what will happen to the tree? What will happen to the tree? the tree will get exactly opposite, the tree will get a velocity which is exactly in the opposite direction as that of the car, and that would be minus 10 meter per second. And that would be minus 10 meter per second. Even the bus will get the velocity in exactly opposite direction. बस को भी एक वेलोसिटी मिलेगी माइनस 10 मीटर पर सेकेंड, लेकिन लेकिन चूंकि बस के पास अपनी एक वेलोसिटी है 18 मीटर पर सेकेंड, so the net velocity of the bus is actually going to be 8 meter per second. Why 8? Simply 18 minus 10, and that will be equals to 8 meter per second. Okay, so I want you to reflect on this example a bit. क्या हुआ? When the observer was standing by the tree side, he knew that the tree is at rest and the car is moving with 10 and the bus is moving at 18. Now the observer by some mechanism went and sat inside the car, and the first thing that happened, जो पहली चीज हुई वो ये हुई कि that the car comes to rest with respect to the observer. With respect to the observer, the car comes to rest. So observer is inside the car, so the car comes to rest. Okay, and then what is going to happen to the other things? बाकी सब चीजों को क्या होगा? All the other objects that are outside the car will get a negative velocity of the car. Now tree will get a velocity 10 meter per second backwards. The bus will also get a velocity 10 meter per second backwards. But since the bus already has a velocity of its own, that is 18 meter per second, the net velocity as seen by the bus is the net velocity of the bus as seen by the observer will be 8 meter per second, that is 18 minus 10. The summation of two vectors, all you have done is simply added these two vectors plus 18 and minus 10, and the net velocity becomes equals to 8 meter per second. Now if the same observer goes and sits inside the bus, let me move this about. If the same observer goes and sits in the bus, okay, sits or sleeps, I don't know what it looks like, but okay, fine. The same observer goes and sits inside the bus. What happens? The first thing that happens is that the velocity of bus becomes equals to 0. Velocity of the bus as seen by the observer becomes equals to 0. What happens to the tree? The tree gets a velocity of negative 18 meter per second, exactly in the opposite direction, minus 18 meter per second. What happens to the car? The car also gets a negative velocity of minus 18 meter per second. But we already know that car has got its own velocity 10 meter per second. So the final velocity of the car as seen by the person in the bus comes out to be 10 minus 18, that will be minus 8 meter per second. So when the observer goes and sits inside the bus, he thinks that the bus is at rest. The car is moving backwards with 8 meter per second. Let me draw this with a green line. The car is moving backwards with 8 meter per second, the velocity of the car as seen by the bus. And the tree is moving backwards, velocity of tree as seen by the bus is moving backwards with 18 meter per second. So now we come to that particular definition that we were talking about. हम जिस definition की बात कर रहे थे, that velocity of A with respect to B. Let me write this down. What does this mean? This means velocity of A with respect to B. All right. The velocity of A with respect to B. Now with respect to B means, with respect to B means that B is the observer. Now this is very important. When we are saying velocity of A with respect to B, that very specifically means that B is the observer, and velocity of A with respect to B becomes equals to velocity of A, this properly, okay, velocity of A minus velocity of B. And that is how it functions, or that is how it pans out. So this is the fundamental law for velocity in relative motion. And then there is a fundamental law of position of A with respect to B, that is position of A minus position of B. Now if you actually see, these fundamental laws are actually connected to each other. How they are connected? If we differentiate, if we find the rate of change, what do I mean by differentiate? If I find the rate of change rate of change of position with respect to time, I'll get rate of change of position of A with respect to time minus rate of change of position of B with respect to time. Now we all know what does rate of change of position mean. Rate of change of position means velocity. So this is going to be velocity of A with respect to B, and this is going to be velocity of A, and this is going to be velocity of B. As a matter of fact, we can actually differentiate it one more time to find out the rate of change of velocity, and that would be acceleration of A with respect to B equals to acceleration of A minus acceleration of B. So this is what we call as the relative law for relative motion in acceleration. So we have three laws basically. Actually, it's just two laws, but the third law actually kinds of pops up on its own. So the velocity of A with respect to B is velocity of A minus velocity of B. Position of A with respect to B is position of A minus position of B. And the acceleration of A with respect to B is acceleration of A minus acceleration of B. Right? And this is the fundamental theory behind relative motion or relative velocities. Okay, let's solve a few simple problems to see if we do understand how relative motion works. Alright. So this is the first problem. And I'm not going to write the statement of the problem, that doesn't look very natural. So I'll just discuss the problem with you. So we have some kind of a police van, right? And we have, we have a motorcyclist. It's a very bad drawing, but I think you will understand my point of view here. And we have a motorcyclist. The idea is this, that the police van is chasing the motorcyclist. The police van is chasing the motorcyclist, and it's actually 100 meters behind the motorcyclist. The motorcyclist is moving with 20 meters per second, and the police van is moving with 25 meters per second. And the question is that after what time will the van be able to catch up with the motorcyclist? And it's a fairly simple problem. The only thing about this problem is this, that either you look at the motorcyclist with respect to the van, or you look at the van with respect to the motorcyclist. So I'm going to do the second thing. I'm going to look at the van with respect to motorcyclist, because a motorcyclist would be more concerned, he's about to get caught or something like that. So when we are looking with respect to the motorcyclist, you have to understand that motorcyclist is the observer. And what was the rule that we studied about the observer? The rule that we studied about the observer, that observer is always at rest. Okay. So the motorcyclist, and I have to draw this stupid diagram again. Okay, let's see if I can do something about it. Right. So, okay, fine. So the motorcyclist actually is at rest with respect to himself. And he sees the police van 100 meters away. And the van is moving with what speed actually? The van is moving with a speed of 25 meters per second. But also it gets a speed of minus 20 meters per second since the motorcyclist is looking at it. So we can say that velocity of van with respect to motorcyclist is actually equals to velocity of van minus velocity of motorcyclist. And that is going to be equals to velocity of van is 25, velocity of motorcyclist is 20, and that is going to be equals to 5 meter per second. Now considering all this, if we are looking the motion with respect to motorcyclist, तो हमें ये पता चलता है कि मोटरसाइक्लिस्ट सिर्फ और मोटरसाइक्लिस्ट नहीं, वैन सिर्फ और सिर्फ 5 मीटर पर सेकेंड से उसकी तरफ मोटरसाइक्लिस्ट की तरफ मूव कर रही है. But the motorcyclist is at rest. So the distance that the van has to cover is 100 meters. So if the distance the van has to cover is 100 meters, then the time taken by the van is obviously going to be equals to distance by speed, that is 100 divided by 5, and equals to 20 seconds. So this is a very simple problem that the examinations can ask you. But this is a very basic problem that lays the foundation of how to understand and how to use relative motion. So generally we use relative motion when there are two or more things that are moving, and the motion looks simpler if we take any one of those things as our reference frame or as our observer. Okay. Okay, so let's come to a second type of the problem. And this problem will involve the use of relative velocities in two dimensions, that is x-axis and y-axis. So let's see how that problem pans out. So this is your x-axis and this is your y-axis. Okay, and at the origin there is a particle A which is, let's say, moving with 30 meter per second, and this is your x-axis. The particle A is moving along x-axis and this is your y-axis, and at some point below A on the y-axis there is particle B, and we can actually write this distance down. The distance between A and B is going to be, let's say, 100 meters. Okay, and the particle B is moving with 40 meter per second along y-axis. Okay, and now the question that is being asked to you is this, that what is the shortest distance, A और B के बीच का shortest distance क्या है? What is the shortest distance between A and B? अब अगर आप इसे डायरेक्टली करने की कोशिश करेंगे, ठीक है, अगर आप इसे डायरेक्टली करने की कोशिश करेंगे, लेट्स से वी डू नॉट यूज रिलेटिव मोशन, we actually use some other kind of motion. We actually use the direct method. So if we want to do the direct method, don't worry, I'm not going to solve using the direct method. I just want to, take things into perspective कि कैसा हो सकता है direct method से करना. तो after certain time t, A की position हो जाएगी 30t along x-axis, and after the same time t, B की position हो जाएगी, कितनी हो जाएगी, 100 minus 40t along y-axis, और इनके बीच की जो डिस्टेंस होगी ये होगी इनके बीच की डिस्टेंस, the distance that you can see with the blue line. अब ये डिस्टेंस जो है आपकी, इस डिस्टेंस की वैल्यू आप निकाल सकते हो यूजिंग द पॉइंट डिस्टेंस फॉर्मूला. सो 30t होल स्क्वायर्ड प्लस 100 minus 40t whole squared, and this would be the distance between A and B at any point of time, right? You can use distance squared is equals to 900 something t squared plus 100 minus 40t whole squared, and so on and so forth. And then you will have to use calculus, or maybe you will have to use quadratic equations to find the maximum or the minimum distance, find the shortest distance between A and B. So in order to solve the shortest distance between A and B, you will have to use either calculus or quadratic expressions. and that sounds a bit difficult. But now we want to, shorten our solution. हम अपना जो solution है उसको छोटा करना चाहते हैं, because this expression looks very intimidating. This expression here is very, very dangerous looking, right? I mean, t square, then there will be a quadratic function of t, and then you'll have to differentiate it and do what not. But इससे बचने के लिए हम क्या कर सकते हैं? इससे बचने के लिए हम क्या एक काम ये कर सकते हैं कि look at the entire motion with respect to a. Look at the entire motion with respect to a. उससे फायदा एक तो फायदा ये होगा कि a will come to rest. That is one benefit of it. Since a is the observer, an observer is at rest, so genuinely you will feel कि चलो एक ही ऑब्जेक्ट मूव कर रहा है, एक ऑब्जेक्ट रेस्ट पर है, so it would be like कि a रेस्ट पर आ गया. ठीक है, तो चलिए हम देखते हैं हम कैसे कर सकते हैं दूसरे तरीके. ओके, तो लेट्स कंसिडर a as our observer, and since a is the observer, a is at rest. And if a is at rest, then what about b? B will get the negative velocity that a had. What was the velocity that a had? It was 30 meter per second along positive x-axis. So b will get a minus 30 I cap. इसके साथ साथ b का अपना भी velocity था, that was 40 meter per second. तो जो net velocity of b with respect to a will actually become equals to velocity of b minus velocity of a. So velocity of b is 40 j cap and velocity of a was 30 I cap. So the overall velocity becomes minus 30 I cap plus 40 j cap. This is what is being shown in the diagram. So you would recognize from that minus 30 I cap plus 40 j cap. Now since b has such kind of velocity, the path of b is going to be something like this. The path of b is going to be something like this, and we can actually find out the angle of the path, this angle theta, and we can say that tan theta would be equals to 30 divided by 40 or simply 3 by 4, or theta would be equals to 37 degrees. Approximately, not very accurately, but approximately it is 37 degrees. So now since it is 37 degrees, we know that theta equals to 37 degrees. So the shortest distance between A and B, now think about it. B is moving like this, A is at rest. The shortest distance between a point and a line is nothing but the perpendicular distance from the point to the line. This is the shortest distance d. Now how do we find out the value of the shortest distance d? So we do remember कि मैंने आपको बताया था कि this distance was 100 meters and we have a right angle triangle. तो मैं चाहता हूं कि आप इस right angle triangle को ध्यान से देखें. This was 100 meters. This is 90 degrees. This was 100 meters. This distance is d and this is 37 degrees. So obviously d is equals to, now I think you get the point, d equals to 100 sine 37 degrees. Sine 37 degrees is 3 by 5, so that would be equals to 60 meters. So the shortest distance between A and B is actually 60 meters, and you can see कि कितने आसानी से ये solve हो गया simply by realizing a fact that we are not observing motion with respect to the ground or with respect to something at rest, but we are observing motion with respect to A. तो अगर A के respect में motion देखा तो ये कितना आसान हो गया. So this is the fundamental idea behind relative motion. I'll put down more problems in future videos, but मैं चाहता हूँ कि आप इस वीडियो को एक बार ध्यान से देखें और अगर हो सके तो एक बार और ध्यान से देखें, because this video will help you to understand what is happening on the basic level, just on the basic level. Okay.